Welcome to school. Okay, here we go. Okay, so square roots, I've told you guys from the get-go, it's probably one of my favorite things that we learn. One of my favorite things that we learn because one, it's challenging, but two, it's something that I don't recall doing in high school. Doesn't mean that we didn't do it, it just means I might not have been paying attention. So I think it's kind of neat because once you figure it out, it just clicks. So when we do today's lesson, you are going to need to know how to do several different things. The first thing you're going to need to know how to do is simplify a square root, which is what we worked on all last week. The second thing you're going to need to do is identify what the radicand is and be able to understand that the radicand, that's going to be what we refer to as the like term. So the radicand, once we simplify, is going to be our like term, like what we did with this 3a plus 4b plus 5a. And then the last thing that you're going to have to do is add. So go ahead for example number 1, write this down. You have 2 square root 2 plus 3 square root 3 plus 5 square root 2. Thank you.
Is that part up there part of the problem?
No, that was just kind of showing you that that's like terms. We're going to look at these as like terms. Now, the first thing that I said, one of the first things I said to you guys is, you're going to have to be able to look at these square roots and first simplify them. Well, we're going to look at all of our radicands here. So if I look at a 2, can I simplify the 2? No, that's a prime number, right? Can I simplify the 3? No, that's a prime number. Can I simplify or factor the 2? No, that's a prime number. So this first step, you guys don't have to worry about simplifying each square root because they're already in simplest form. So the next step that you're going to look at here is you're going to combine like terms based on the radicand. So when we combine like terms based on the radicand, you first have to be able to identify which number is the radicand. Which number is my radicand? Yeah, my inside numbers, right? My radicand is the number that's inside of the square root. So you're going to combine like terms. Your like terms are based on which radicands are the same. Much like how we combine like terms in ABC order up above, we're going to combine like terms least to greatest. So what's my smallest radicand here? 2. So, whoops. So we're going to look at this one. And then what's my other one that has the 2 as a radicand?
5.
Square root 2. What's the operation sign in front of that 5? The plus, right? That goes together. Now, what does not have a like term with it?
3.
So that's going to be the odd man out. So what we're going to do, when you combine or you add square roots, you add the coefficient. Okay? So we're going to add the coefficients together. Our coefficients is the outside number. So we find the radicand of the like terms, and then we add the coefficients because we have 2 plus 5. So what's 2 plus 5?
2 plus
7. Now, the radicand stays the same. It does not change. So it's going to be 7 square root. If the radicand stays the same, it's going to be 7 square root 2. Okay? Now, we don't have anything to combine with this one, correct? So we just bring it down. What operation sign do I bring down with it? Plus 3 square root 3. That's my final answer. Say again? Just to kind of get you thinking of like terms.
I think I understand it, but like, why is this the odd man out?
Because do you see how that radicand is a 3? It doesn't have any other like term, anything like it to combine it with. So you can only combine radicands that are the same.
Okay.
Like what we did on that 3a plus 4b plus 5a. Remember how we only combined the a's? Well, we didn't have anything to combine the b. Okay, let's look at this second example. Now, I am going to promise you, as I do each and every time we do notes, every problem is not already going to be in simplest form for you. You're going to also have to put together simplest form, then do the step that we just did. So let's take a look at this next one. So example number 2. The square root of 27 plus the square root of 18.
We just put a 1.
You telling me we have
Well,
fraction?
that's a really good point, but I want you to hold on to that thought. Not yet.
Okay.
So Damon had a really good question. He's like, are we just going to put a 1 in the coefficient place because there's nothing there? Not yet. Because if I look at the square root of 27 plus the square root of 18, what do I have to do to these numbers first?
You're gonna find out. You're gonna hook them up.
I'm going to hook them up. What does that mean?
Fraction then?
No.
Not fraction them.
No.
What did we do all last week?
That's what I'm saying. You gotta hook them up.
What does that mean? What's that called though?
You know what I'm talking about.
Starts with an S.
So far.
Simplify. So I have to simplify each of these square roots. So this is why all last week we worked on simplifying square roots. Hey, I need you to pay attention, Mike. I need you to set up and not sleep. And I need you to set up, all the way up. I don't want your head down, and I want your eyes up here. I actually want you writing the notes down, because if Miss V writes them down, you're learning nothing. So you're just sitting in here sleeping does no good for you. So notes go to him. He needs to write them down.
Started before you.
Okay, so we have the square root of 27. The first thing we need to do is hook them up, as Damon said, which means simplify. So I think of what two factors can I multiply together to get 27, Damon? 3 and 9. You guys should be pros at this part right here.
Oh, yeah.
So what I'm going to do before I drop down, I'm going to go ahead and factor the 18 too. So what two numbers can I multiply together for 18? 2 and 9. Okay. Now, when I drop down, I'm going to put my equal sign. I'm going to put my square root sign. So this is the square root for square root of 27. So what do I put under this square root sign?
3.
Okay. Then what operation sign do I bring down? Plus. And then I put in my other square root. And what numbers do I put under this square root? Good. Okay. Give you guys a second to get that down. Okay. So once we do that part, once we factor it, what's the next thing that I do for each of these? Kyle?
Circle your pairs.
Yeah, circle my pairs. So here's a pair. They cancel. Here's a pair. Then they cancel. So then I go to the next step. So this square root, that 3 cancels, gets kicked out of the square root sign and moves to the outside, the coefficient. What's left on the inside is the radicand. Okay. I bring down my plus sign. Then I'm looking at the square root of 2 times 3 times 3. The 3 cancels. It gets kicked out and moves to where? Where does this 3 cancel out and move to? What happens to that? Give me 5 seconds.
Goes outside.
Goes to the outside. So then what's stuck on the inside? The 2. Now from here, I need to look. I have to look at my radicands to see if they are like terms. Are my radicands the same here? Are my radicands the same?
Why is there so
My
many?
inside numbers, are they the same?
No.
No. So do I have any like terms up here? No. But I need to put these in order. Are these in order based on least to greatest on my radicands?
Let me just switch them around.
Yeah, exactly. Why? Why are we going to switch them around, Kyle?
Because the 2 is it's the lowest number.
So what am I going to rewrite?
I don't got my stamp, so I'll give it back to you.
Perfect. Thank you. So I'm just going to switch them around. So what do I write?
3 to the square root of 2 plus 3 to the square root of 3.
Perfect. And that's it.
Okay, think about this. Is already too much.
It is a lot. I'm not going to lie to you.
There was no need to flip.
You have to. Yes. When you say your ABCs, do you say C, A, D, F, K, Z, L? No. You say them in order, right? A, B, C, D. So, just like this, you're going to have to write them in order, least to Smallest to greatest based on your radicand.
Say your ABC backwards.
Okay. Do you all have this down? Okay, let's look at example number 3. David's like, forget this, I'm over this, I'm throwing my pencil. Okay, now, what's different about example number 3 compared to example number 2? Subtraction signs. And how many square roots do you have? 4. Okay? I'd really rather you not. You've already gone through this during the class period. So, we have the square root of 8 plus the square root of 100 minus the square root of 32 minus the square root of 16. Yeah, I have some different operation signs in there. You're going to start this off just like what we did for example number 2, though. How did we start example number 2 off? What did we do with each of the square roots? We started simplifying. We started factoring them. So, go ahead and start factoring them. If you already have this down and you're waiting for other people, go ahead and start factoring them. It's okay. We'll get to that point. Don't worry about the different operation signs. It's not going to be a big deal. Promise. We'll get through it. Yeah. Okay. So, Alex, factor the 8 for me. I'm going to have to write small. Okay? Who can do 100 for me?
Me. 10, 10.
Okay?
5, 2. 2.
Okay? 32. Kira, factor the 32 for me.
4 and 8.
Thank you. Say it again.
4 and 8.
4 and 8. Okay, keep going.
The 4 is 2 and 2. 8 is 2 and 4. 4 is 2 and 2. Yeah.
Thank you. Okay. And then the 16. Michael, go ahead and factor the 16 for me. Go ahead and factor the 16 for me.
You're going too fast. I haven't started.
That's okay. Factor the 16 for me.
Eight and 2.
Okay. Then what?
4 and 2.
Okay.
2 and 2.
All right. So go ahead and get that down.
You're going too fast.
Okay, this is what I need to tell you. When you throw a little fit and you slam your fist down, that doesn't help or do anything. So you need to try to write them down. And if you get to the point that like you're writing and you're trying and you're not able to get it all down, that's when Miss B can help. Okay? All right. The next thing that I'm going to do is come down and put each of these prime numbers under the square root. So when I drop down, I'm going to make sure I put an equal sign. So I'm going to put my square root. What are my numbers for my 8? Danielle? Okay. I don't like that square root sign there. Ugh. What's the operation sign I bring down then? What's the operation sign that I bring down? The plus. Okay. Not yet. So now I bring down, what are my prime numbers for the square root of 100? What are my prime numbers for the square root of 100? 2 times.
2, 5, 5.
Good. And what's the operation sign I bring down after that? Minus the square root of, put your square root sign in there. How many 2's, Alex? How many? 5, there we go. What operation sign comes behind that one?
How many 2's is there?
5. 1, 2, 3, 4, 5. Sorry, I started writing smaller so I could fit it. 1, 2, minus, good. The square root of what?
2.
Times, thank you, I appreciate it. So times 2, times 2, times 2, times 2. And I heard what you said, and you're right. We'll get to that in a minute, though. Thank you. Appreciate it. Okay, now, Kaylon, you said, well, don't we circle them? This is where now I'm going to go through and I'm going to circle all my pairs. Okay? So I'm going to go through. For the square root of 8, I have a pair. What about for 100? I have a pair of 2s and a pair of 5s. They're going to cancel. Pair of 2s, another pair of 2s that cancel, move to the outside.
I can't do that.
Wait, the second one doesn't have a radican.
We're going to get there. So, there's a couple things here that Kyle noticed, but before we get to what he noticed, we're going to look at this one. So, the square root of 8 in simplest form is going to be what? 2 square root of 2. Bring down my operation sign, which is a plus. Now, what happened? Both of my square roots canceled with the square root sign.
So you roll both of them out to the outside.
So if I write them both to the outside, what's 2 times 5? 10. So it's not going to have a square root sign, is it? So the square root of 100 is a what?
Perfect square.
There we go. Nice. So do you all understand how I ended up with just the 10 here?
Sure.
If you do not, you need to let me know so I can show you. You do not? Okay, so it's okay. No, I want you to understand it. So this 2 here, look at me, moves to the outside, right? What else moves to the outside?
Okay, cool.
The 5. Well, what's 2 times 5? So instead of writing that, I just went ahead and put in my 10.
So they pairs.
Right.
Okay, so
What's my operation sign I bring down?
2.
Addition.
Hold on, minus.
Minus. Okay. Now, I have 2 2s that are canceling and moving to the outside. So how many 2s am I moving to the outside? 2 times 2, which is
4.
4. And what's on the inside?
Square root of 2.
And then what operation sign do I bring down?
Subtract. And then your other one has 2 of them that's in the circle together.
They both
They
cancel.
both cancel, they roll outside and make a 4.
So Alex, that's what you're saying. The square root of 16 is 4. Yeah, you're absolutely right. Because they both cancel with the square root sign, which means the square root of 16 is a perfect square. Now, somebody said, well, some of these don't have radicans. You're right. So if they don't have a radican, we're going to deal with those first. Those are going to be the like terms. If they do not have a radican, those are going to be first because that's basically like a 0. Okay, so I could really write it as 10 square root 0. Well, 0 is smaller than the radican of 2, right? So the like terms that we're going to combine first are our whole numbers. So we look at the operation sign in front of our whole numbers. So our first whole number is what, you guys? 10. What's the operation sign in front of it? What's the operation sign in front of the 10? The plus. So the plus 10, and then what's my other whole number? And what's the operation sign in front of the 4? Say it again. Minus. So we have positive 10 minus 4. So what's 10 minus 4? 6. Now, I'm done with those 2. So now I'm going to look at my next like terms. Square roots have similar like terms if they have the same radican. Do I have like terms? Are there 2 square roots up here with the same radican?
Yeah.
Yes. So we have 2 square root 2 minus, because I use the operation sign in front of it, minus 4 square root 2. Now remember, my radican stays the same. So my radican is going to stay a square root 2. So then I'm going to subtract my coefficients. So what's 2 minus 4? What kind of 2?
Negative 2.
So my answer is going to be 6 minus 2 square root 2.
Now what if you would have had 3 square roots?
Say it again.
Now what if you would have had 3 square roots and your last square root wasn't the same 2 as the other 2?
We're going to get to that. I'll show you that.
Yeah, let's do that tomorrow.
No, we're not going to. Well, we might do that tomorrow.
15, one man, they tweaking to it.
Okay, let's look at the next one. Example number 4. Oh, I gave you guys a smaller one.
Yes.
It's gonna be longer.
We'll have to wait and see.
You try that one?
Since it's a smaller one. Awesome. I like to hear that. Okay, so you guys at this point should know what to do. I apologize. If you flip your notes over because you ran out of room, that whole back side is blank. We don't have notes on the back of them. I write big too. There's no way I could have fit all my work on this stuff, so I apologize. So if you ran out of room, just put example 4 on the back. Just draw an arrow so you know you wrote it on the back and put it on the back so you have some room. So example number 4, we have the square root of 12 plus the square root of 27.
12 is a perfect square.
Nope.
Yes.
Nope.
Oh, wait, no. I'm
Nope.
thinking of
That's
that.
okay. Okay, that's all right.
It's okay.
It's okay. Yeah. All right, Alex. What are the factors of 12?
2 and 6.
3. Okay, you want to do 2 and 6 instead?
No, do
2 and 6.
6.
Okay. And then for 6?
2 and 6. Oh, yeah, I drew.
I read your mind. We're together. Kaylon, what do you want to do for 27? Go. Why do you have your phone out? No. Take that phone with you. Go downstairs and deal with it. Say it again. Okay.
3 and 3.
Okay.
That's it.
That is it. So now we're going to drop down. Put my equal sign, my square root sign. For the square root of 12, what factors do I write in?
2 times 3.
What operation sign? All y'all. What operation sign do I bring down?
Addition.
And then the square root sign. And then what do I bring under for the square root of 27?
2 times 3 times 3.
Now what? Circle my pairs. Circle my pairs. Okay? And when I go to rewrite them, the square root of 12 in simplest form is what? Jair? What's this? The square root of 12 in simplest form is what? That 2 cancels with the square root sign and moves where?
Outside.
Okay, and then what's left on the inside?
2.
What's left on the inside?
The 3.
The 3. So I bring down my plus sign. Okay?
And
The square root of 27 will be
3 goes on the outside and 3 left over. And the 1 left and 3 left over.
good. Okay. Almost done. Almost finished. Now, I'm going to combine like terms. Do I have like terms here? Are my radicans the same?
Yes.
Yes. So then I combine my coefficients. So if I combine my coefficients, I'm going to take 2 plus,
3.
which
That
equals,
5
and then what's my radican?
of 3. What's the homework? No homework.
That's not that bad.
See you tomorrow. So the homework,
Homework.
well, I really want you guys to write this down. So, you have time. Write it down. I will pass that your homework while you guys are writing this down.
No time, whatever.